Bingo. All righty then. So we are going to talk about two major things today. One thing is called arcs. The other one is called sectors. We'll get to sectors later. We're going to start with arcs. So in red, simple question, what is an arc? And if you don't physically know what an arc is, I will show you. This portion, green's a bad color, hold on. We'll do red. This portion is called an arc. And so again, I ask the question, what is an arc? How would you define that red thing? Zoomers at home, if you want to contribute, or when you do contribute, you're going to have to unmute and talk because I'm stepping away from my computer. And obviously, roomers, you're just going to give me an answer without having to unmute. Well, actually, you would have to unmute because in order to speak, you have to unmute yourself. So, what is that red thing? How would you define it? Going once, going twice. Sold. Let's pick on somebody. Let's go here. Colin, what do you think? What's that?
Portion of a circle.
Love it. Can I tweak it a little bit? All right, I'm going to change portion because that sounds too fancy to a chunk of a circle. And hopefully that makes sense to everybody. Makes sense to me, makes sense to Colin, hopefully it makes sense to you. It's just a piece of the circle. So with this lesson, one thing you want to do is keep it simple. Okay, when we get to doing some calculations, everything that we deal with is just going to be a simple application. And I'll continue to refresh that. Okay, so how do we name an arc? Well, there are three different types of arcs, which we'll get to in a second, but we still don't know how to name it. So this arc here from A to B, we name it by using the same notation we've used for everything else. If we were talking about a line segment, we put a line segment over it. We talk about an array, we put an array over it. So just like this, if we're talking about an arc, you put an arc symbol over it. Now, getting into the three different types of arcs. One thing we've used before, if you'll recall, that is a theta. It's a Greek letter, and we commonly use theta to represent an angle measure. So we're going to pretend we don't know that's 50, and we're just going to call that theta. So we'll say theta is equal to 50. There are three different types of arcs. First of all, hopefully you all realize that our arcs are going to be measured using angles. Okay. And those angles correspond to the angle at the center of the circle. Okay, so notice, if this angle BXA is 50 degrees, then this arc would also be 50 degrees. Okay. And again, that's called the arc measure. If the arc is 50 degrees, the angle is 50 degrees. If the angle is 50 degrees, the arc is 50 degrees. And that leads us to three different types. All of these angle measures have to be between 0 and 360, which gives us the full circle. The first type is called a minor arc. Theta has to be less than 180, but greater than 0. Because obviously if it's 0, you don't even have an arc. And again, that's named using two letters with an arc over it. Now, one way you may want to think about that notation is AB with an arc over it means go from A to B along the circle as quickly as possible. But what if I want to go the other way around? What if I want to go from A to B, but I want to go the farther way around the circle? How do we represent that? Well, that is what's called a major arc. A major arc is going to be greater than 180, but less than 360. And we have to figure out a way to distinguish which one we're talking about. So if I give you a problem and I say arc AB, the question would be, well, which arc AB? The red one, which is a short guy, or the green one, which is the big guy. And the way we distinguish that is major arcs are named with 3 letters. Still have an arc symbol over it, but now you use 3 letters. 2 letters means go from A to B as quickly as possible. 3 letters means go from A to B, but pass through C on the way. Okay, rumors, does that make sense? Yeah. Zoomers, does that make sense? Give me a thumbs up, please.
Wait,
Go.
what's the circle in the first one? What does that mean?
That's a theta.
Theta.
Okay, it's just a way to represent an angle measure. So in other words, some angle measure or some arc measure has to be between 180 and 0. Okay, we could use X, but we're big people now. It's time to come off the porch and run with the big dogs. Okay. Semicircle. Exactly 180 degrees. And for a semicircle, we also have to use 3 letters. The reason we need 3 letters for that is because we have to distinguish which way you're going around the circle. Okay. So if I take this and I draw this diameter in, and I call this point E, I can talk about the semicircle A, B, E. That yellow's a horrible choice, I apologize. Go from A to E, but pass through B. I can also call it ACE. Doesn't matter, just some point on that semicircle. If I want the other semicircle, I have to choose a new point, or I got to put a new point on there. Okay? Again, these are called arc measures. Okay, so if the arc AB is 50 degrees, how big is the arc ACB? If the red arc is 50, how big is the green arc? Go. Oh.
310.
Wow, you threw your voice. It sounded like it came out of the computer. That's such a great skill. And it sounded masculine. You should take that act on the road like America's Got Talent or something. Who said that over here?
That was me.
Okay, Ethan, thank you. 310, is that what you were going to say? No? Yeah, 310. How'd you get that, Ethan?
Well, the circle's 360 degrees, and the little red area it was 50, so I just subtracted it.
Beautiful. Well done. Okay, questions? All right, well, let's change things up a little bit. We've talked already about naming the angles and naming the arcs. Okay, so now I've got this arc AB. Its arc measure, let's go back to blue would be bad, we'll use pink. Its arc measure, so AB would be equal to 50 degrees. Okay. Because that central angle is 50 degrees, the arc measure would be 50 degrees. Okay, nothing fancy there. We've talked about that already. However, now we want to calculate the arc length. Well, what is an arc length? An arc length is the actual distance you would travel going from A to B if you walked along this circle. Okay. So arc measure is an angle measure. Arc length is an actual distance. This will be fun. How would I find the length of that green arc, knowing that its arc measure is 50 degrees? And I don't necessarily care about the answer now, I just want to know the method. What method would you use to find the length of that arc? Any suggestions?
Minor.
Yes? Keep going. But how would you, yeah, it is a minor arc, but how would you find its length? Okay, so let's change the problem a little bit before we dive into the green one. Let's change colors to white. Let's suppose I did this. And then we'll shade this guy in. Whoa, that's horrible. How would you find the length of that big honking white arc?
You find the circumference, and then split it in half.
Perfect. Okay, for those of you at home, if you didn't hear him, he said, find the circumference and split it in half. Well, why split it in half?
Because it's half the circle.
Perfect. How do you know that it's half the circle?
Because it's on the diameter.
Couldn't have said it better myself. Now, I'm going to change the problem for you. You're not going anywhere. You're not off the hook yet. Okay? So instead of that arc, get rid of E. I'm going to erase a whole bunch of stuff there. Okay. I'm like a bull in a china shop. Okay, let's do this one. How would you find the length of that arc?
You find circumference and then split it into 4.
Perfect. Okay, now, let's take that idea and go back to the green one. How do you find the length of the green one?
Find the circumference and then so would it be?
You're right there. Somebody help Aiden? Okay, so let's review.
Oh wait.
Oh, you got it.
Do 360 divided by 50.
Oh, so close. Think about what you just said.
Or 50 divided by 360.
Perfect. Okay, why?
Because it's 50 degrees and like if you were to add up like the right angle, 90 plus 90 plus 90 plus 90 is 360. So I don't know. I just
100% correct. Okay, so what he's saying is that green arc, well, let's go to the white arc. That white arc is 1/4 of the circle. How do we know it's 1/4 of the circle? Well, he said 90 plus 90 plus 90 plus 90 equals 360. However, if you take 90 over 360, 90 over 360 is 1/4. 180 over 360 is 1/2. So what we're doing here, and this is where the keeping it simple process comes in, we are simply taking a portion of the circumference, or a fraction of the circumference, or a percentage of the circumference. And where do we get that measure? We get it from what Aiden described by taking the arc measure, dividing it by 360, and multiplying by the circumference. Okay, so before we do the example here, is everybody following that idea? Not the calculation, just the idea. We're good? That makes sense. Okay. And you can phrase it however you want. The fractional part of the circle, 50 over 360. The percentage of the circle, 50, 360. I'll do all that business, find a percentage. The fractional portion of the circle, 50 over 360. So for this example, I would say the arc length is equal to 50 divided by 360 times 2 times pi times 7. All right, bust out your calculators. Tell me what that's equal to. And my units here would be meters. Okay, because it's a length, my units are going to be in a linear measurement. Meters, inches, feet, miles, whatever it is you're using to measure it. Okay. So again, keep it simple. If you can find the circumference of a circle, which I know you all can, then finding an arc length is just a matter of taking whatever part of the circle we're talking about. Okay, we're good? Excellent. Okay, well, where do we go to next? You'll notice that on this slide I colored in the circle. Remember, the circle is only the black outside region. The pink part is called the circle interior. You know how to find the area of that thing. Right? Okay, so there's the whole circle. What if I get rid of this? That pink region is now called a sector. Colin, what's a sector?
Just a chunk of the circle's area.
Beautiful. I knew I could count on you. You guys know the game Trivial Pursuit, or is that after your time?
Yeah.
Yeah, so you know, they're like,
Little game pieces.
yeah, they're Trivial Pursuit pieces, or
Mhm.
pie pieces. Okay, is a sector. All right, well, area of a circle, we know that. That's pi r squared, no problem. All right, Aiden, coming back to you. How would I find the area of that pink region?
You find like the area of the whole thing and then do 50 divided by 360 times the area.
I also knew I could rely on you. It's, again, a portion of the overall circle. You know how to find the overall circle area. Okay, in this case, it would be 49 pi. So to find the area of the sector, it's 50/360ths of that 49 pi. 50 over 360 divided, or times 49 over pi, which would be approximately, little help please. I did not get the right answer. What do we got? Anybody? Bueller? Help?
21.38
What are my units?
meters or meter square.
It's an area unit, so it'd be meters squared. Okay? Questions? Go.
What does AM stand for?
Excellent question. AM stands for arc measure. So here, let me include that here. AM is arc measure. And that would be in degrees. And AL is arc length. Whoops. Arc length. And that would be in some linear unit. Feet, inches, yards, miles, whatever you want to use. Okay? Good. Any other questions for clarification? We're good? Okay, so similar to what I'm going to talk about with the day 2 homework, we want to keep this simple. And you also want an understanding of what you're doing. Instead of just plugging blindly into a formula, which never works in the long run, you want to understand what you're doing. If I give you that entire circle to find the area of, you all know how to do that easily. Well, what happens when you want to do a sector? A sector is simply just that chunk of the entire circle, as Colin mentioned. Okay? So find the entire circle and figure out what percentage of the circle we're talking about. Okay, we good? Questions? No? Questions at home? No? Beautiful. Okay, so let me stop this.